Load test on three-phase induction motor. This is a direct method of testing any given three-phase induction motor. The main objective of this experiment is to obtain the various performance characteristics of the given three-phase induction motor. Now, if at all any motor has to be chosen for a specific application, we have to first check whether the characteristics of the given motor is compatible with that of the application, and then only we can say this motor is apt for the given application. So load test is a primary test which is conducted on any given three-phase induction motor in order to study how this motor behaves when connected to the load. You can see the circuit diagram. We require a three-phase AC supply here of 50 Hz. Then we require an auto transformer, three-phase auto transformer. These are the input terminals of three-phase auto transformer, whereas these are the output terminals. From the output terminals, we are taking the connection to the motor through meters, that is ammeter, voltmeter and 2 wattmeters. Now we have two identical wattmeters here. Basically we are following 2 wattmeter method to measure three-phase power. And here is the belt with brake drum arrangement. These are S1 and S2 are the spring balances using which we are loading the motor. The nameplate details of the machine on which we are conducting this load test is shown here. So the rated voltage is 415 volts AC, current is 7.5 amperes, power rating is 3.7 kilowatt, speed is 1430 RPM. So these are the parameters which you have to note down. I repeat, rated voltage is 415 volts, rated current is 7.5 amps, rated speed is 1430 RPM and the rated output power is 3.7 kilowatt. For this experiment we need a three-phase supply. Then we require a three-phase auto transformer and we require one voltmeter to read the line voltage of range 0 to 600 volts. Then we need one ammeter to measure the line current. Depending upon the machine rating, we have to select the range of the ammeter. So here the machine on which we are conducting the experiment has got the rated current of 7.5 amperes. So we will choose the ammeter range to be 0 to 10 amps. Then we are using 2 wattmeter method here in order to measure three-phase power. So we have two identical wattmeters, W1 and W2, two identical wattmeters. These are unity power factor wattmeters. And then to load the given motor, we are using a belt and a brake drum arrangement. And these are called spring balance. Initially we have to adjust the weights or the scale to 0. That is, the rotor should be free for rotation. Now this is a three-phase auto transformer where we have 3 input terminals and we have 3 output terminals. So to all these input terminals we have to bring the supply R, Y, B points. So you can see here, so R, Y, B from the panel supply is brought to the input terminals of auto transformer. So R phase from the supply should be connected to the input R of auto transformer, Y should be connected to input Y of auto transformer. Similarly, B from the supply should be connected to the B phase of the auto transformer. The next connection we will start from the output terminals. So this R phase has to be connected to ammeter. Now because this is AC, polarity is not bothered much. So we will connect to ammeter. Other end of the ammeter we are selecting 0 to 10 amperes. So this has to be taken to wattmeter. So in wattmeter we are connecting it to M terminal. Now to the same M terminal, M and C of the wattmeter has to be shorted. So M and C of the same wattmeter should be shorted. We have two connections to the same terminal. One is from the common terminal of the same meter, whereas the other one is from ammeter. And L terminal should be connected to the R phase of the stator winding in the panel as shown in the circuit diagram. Now taking the Y terminal from the output of auto transformer. Now this has to be connected to the V terminal of the wattmeter. Now we have 3 options for the voltage terminal, 75, 150 and 300. We will have to select 300. From Y terminal of the output auto transformer, we have to connect it to the V terminal in the wattmeter. Now you can see here there are three options for the voltage terminal in the wattmeter. One is 150, other one is 300, third one is 600 volts. Now the voltage terminal which we have to select here for this experiment is 600 volts. So I am connecting the Y point to this V terminal of W1. Now from the same point, as you can see in the circuit diagram, both V terminals of W1 and W2 has to be shorted. So from that V terminal 600 volts, I am bringing it to the 600 volt voltage terminal of W2. And from the same point, another connection has to be taken, and that has to be given to the Y terminal in the panel, that is nothing but the stator winding. So basically the auto transformer output terminal Y, the machine terminal Y and V terminal of both W1 and W2 will be shorted. The next is B phase. Now this B output terminal from the auto transformer has to be connected to the M terminal of W2, and from same M terminal one connection has to be given to common terminal, that is basically M and C of W2 is being shorted. V connection is already completed while completing the Y phase. So the last connection is L terminal of W2. So this L terminal of W2 should be given to V point here in the panel to the stator winding. So this is the ammeter and wattmeter connection. The last connection will be voltmeter. So here the range of the voltmeter what we select should be 0 to 600 volts because it has to measure 3-phase voltage. So that has to be connected to the output terminals of auto transformer, any two output terminals, either RY, YB or RB. Any two terminals of the output of auto transformer, the voltmeter has to be connected. Before we switch on the supply, here we have to ensure that the auto transformer is kept in its minimum position, that the auto transformer is in 0 position, and load should be 0. These two conditions has to be ensured before turning on the supply. Switch on the supply. Then we have to vary the auto transformer to apply the voltage across the machine. So look into the voltmeter and gradually vary the auto transformer. We have connected, or we are using the scale 0 to 600 volts. So we have to check for the upper scale reading. Let us adjust the voltage of the machine to 400 volts. So you have to ensure that the voltage across the voltmeter is 400 volts. Now under this condition you have to note down the no load readings. Under no load condition, the current here, lower scale reading, it is around 3.5. Wattmeter W1 is reading around 50 watts, 100 watts. Whereas here in W2, the reading or the pointer is beyond 0, so that indicates that this is negative. In order to record this reading, you have to turn off the supply once again. That is, reduce the voltage to 0, switch off the supply, and interchange the terminals of M and L. Only when the wattmeter pointer is kicking beyond 0 terminal, 0 point, we have to interchange this M and L. Now once this M and L terminals are interchanged, the reading of the wattmeter where we have done this interchanging, we have to note down it with a negative sign, that is W2. Remember, only W2 has been interchanged. So switch on the supply again, vary the auto transformer and apply the voltage of 400 volts. Current remains same now under no load condition, it is 3.5 amperes. W1 is reading around 100 watts, whereas W2 is reading now around 50 watts. But here W2 should be minus 50. Now S1 and S2 are 0. To load the machine, we have to just tighten the belt. So now the load what is applied is around 3 kg here in S1, whereas S2 it is 1 kg. So go on applying the load until we get the reading in the ammeter as 4 amperes. Now I have adjusted the current as 4 amperes and the corresponding S1 and S2 readings you can observe here. S1 is 10 whereas S2 is 3 kg. So current is 4 amperes. You can observe here W1 is showing around 170 whereas W2 it is little beyond 0. So now again we have to interchange the M and L terminals. So again you have to make the load 0. Reduce the voltage in the auto transformer to 0, switch off the supply and then interchange the terminals of that wattmeter where it was indicating the reading beyond 0. Remember, only M and L terminals has to be interchanged. So now we are going to the initial connections where we have 2 connections to M terminal and 1 connection to L terminal. Now switch on the supply, apply the voltage of 400 volts. Vary the load to adjust the current to 4 amperes. Now you can note down the readings. It is the W1 is 165 watts whereas W2 is around 20 watts, but this is plus 20, reading is positive. So along with voltmeter, ammeter and wattmeter reading, we have to note down speed as well as the load under each step. So we have to go on applying the load up to the rated current of the motor, and we can increment the current by 0.5 amperes or 1 ampere and take down the reading up to the rated current. Now the rated current of this machine is given as 7.5. So go on incrementing by 1 ampere. After 4 we will note down for 5. After 5 we will note down for 6. And after 6 we will note down for 7. And the last. So up to 7 amperes we can note down the readings. Now here the motor is adjusted to 7 amperes. The reading in S1 is 26 kgs whereas in S2 it is 7 kgs. You can see the ammeter reading. The reading in ammeter is 7 amperes. So the corresponding reading in W1 and W2 can be recorded along with the speed. So this is the procedure for conducting load test. Once the rated current, that is 7 amperes in the ammeter is reached, we have to reduce the load and bring it back to no load condition. We have to bring the machine back to no load condition, that is initial position the current was 3.5 amperes. So reduce the load and bring it to no load condition. Then reduce the voltage to 0 and switch off the supply. So by conducting the experiment, we will note down voltage, current, 2 wattmeter readings, W1, W2, and then the load reading S1 and S2 in each step. So we can increment the current in the steps of 0.5 amperes and take down the reading only up to 7 amperes. So you can note the corresponding readings at each loading conditions. So once these readings are noted, to complete the calculations, we have to find out few more parameters, that is torque, input power, output power, efficiency, and then power factor and slip. Now there are set of formulae which has to be used in order to record or calculate these values. So we have load S1 and S2. We have to note down the radius of brake drum. So by using scale we can measure the radius of brake drum. Now the radius of brake drum for this machine what we have used is 0.11 meter, 0.11 meter. So radius being 0.11, we have to take the difference of load in each condition. It is not subtraction, it is difference. So whichever is greater should come first. So difference we will take, multiplied by radius, we get torque. Then we have two wattmeter reading, one is W1, other one is W2, but we have got one reading of W2 in negative. So in that case you have to take along with the negative sign and find out the total three-phase power. Once you get the input power, we have to calculate the output power by using the formula 2 pi n. N is the speed in RPM which we have noted down. T is the torque which is calculated, divided by 4500. This gives us the power in horsepower. To convert that HP into watts, we have to multiply it by 735.5. Once we have got the values of output power and input power, take the ratio and multiply it by 100 in order to obtain the efficiency in percentage. Then to find out the power factor, it is give a formula what has to be used is input power by root 3 into V into I. V is the voltage, I is the current which we have recorded at each step. And slip is given by the formula Ns minus N by Ns. Ns is the synchronous speed. N is the reading which we have noted down. Now to calculate the synchronous speed, we have the formula that is 120 F by P. The frequency of the supply is 50 Hertz and the number of poles of this induction motor is 4. So 120 into 50 by 4, the synchronous speed will be 1500 RPM. So Ns is known. At each step N keeps on changing as load changes. So corresponding value of the slip at each loading condition can be calculated. Once these calculations are done, we have to plot the performance characteristics. That is nothing but we will get the various graphs of the machine parameters with respect to output power, like efficiency curve, power factor curve, torque curve, speed. All curves has to be plotted.